Great. Okay, now we're actually going to get started. So presenting now is Dr. Haiwei Zhang, an associate professor at the Institute of Global Environmental Change at Jiao University. He received his PhD from the Institute of Earth Environment at the Chinese Academy of Sciences. He held a postdoctoral position there, and then also worked as a visiting scholar in the Quaternary Geology Group at the University of Innsbruck. He's used high resolution and precisely dated speleothems from China to reconstruct East Asian monsoon variability over interannual to orbital timescales. And he also has an interest in speleothems from northeastern Brazil and reconstructing ITCZ dynamics there. So this presentation will provide an overview of the drivers of oxygen isotopes in paleoclimate archives. So take it away.
Thank you, Jim. Okay, good afternoon, everyone. It's my great honor to be invited to give a talk about the spectrum oxygen isotope, and thank you very much for the invitation. First, I give a short introduction about our lab. I'm from Jiao University, Institute of Global Environmental Change, and I'm from Professor Hai Cheng's group. And now in our lab, we have uranium thermal and also uranium electric dating and stable isotope, triple isotope, and also fluid inclusion, trace element, and also organic geochemistry. Yeah, we almost have full of all the dating and the proxy measurement in our lab. Here just show some equipment and like a super clean lab. We have two Neptune, one is for uranium thorium dating, one is for uranium lead dating. We have Picardo, also we have three MAT 243, and also we have LIPS, this scan for trace element scan. We also have some new technologies such as we use percum catalyzed method for O17 measurement. We also use Picardo analyzer connect with the vacuum crusher for the fluid inclusion measurements, and also like the LIPS can be used for the trace element. We also collaborate with another lab in our university. This is use of focal laser fluorescence microscope for laser counting. We really can get very clear layer bondings, and just we can count very clearly. Okay, my presentation includes three parts. First, I will introduce the spectrum oxygen isotope and also the records in the East Asian summer monsoon region. Second, I will introduce the interpretation of spectrum Delta-18 proxy and also the debates in East Asian summer monsoon region. The third part, I will give some examples from different time scales. As we know, stalagmite has rapidly developed into one of the most important geological archives of paleoclimate research. It has many advantages, such as the precise uranium thorium dating, and also high resolution proxy, and long-term scale and wide distribution. Like Professor Henderson from Oxford, he said, for paleoclimate, the past 2 decades have been the age of ice core. The next 2 may be the age of spectrum. Why? I will also explain in the following. For Solanzan, have 2 important advantages. One is the precise radioactive age. Second is high resolution proxy, such as like oxygen and carbon isotopes, and also trace elements, and oxygen isotope is the most widely used. So I will introduce oxygen isotope. Hulun Cave Delta-18 records the first time show very good correlation with Greenland on millennial time scale for example, this Heinrich event. So it's suggesting that the East Asian summer monsoon can be influenced by the climate in the high latitude. That paper published in 2001, the first time showed the correlation between monsoon region and high latitude. After that, in 2004, Dongge Cave records shows that Asian monsoon is driven by the North Hemisphere summer installation. So the installation also triggered the final rise to the full interglacial conditions. We can see, very clear. Another pioneer work from South America is Chico's work in 2005. It also shows the insulation drives the atmospheric circulation in the past 116,000 years ago. A composite record of specimen from Hulu, Dongge, and Sanbao Cave built the Asian monsoon intensity record during the last 640,000 years ago. This record further confirms that the East Asian summer monsoon was driven by the North Hemisphere summer installation. We can see very clear, and each four glacial termination was separated by 4 to 5 precession. So I also would like to suggest these papers and all these papers published on the special issue, like Asian monsoon actually mainly talk about the East Asian summer monsoon, also the Indian summer monsoon, and South American monsoon region, and also African monsoon. So all these papers is from the tropical, subtropical monsoon. This paper shows the location of published specimen records in China. We can see most of the cave was from central China and southeast China. In southwest China, in southeast China and northeast China, only have a few records. So this cave is the location of Hulu Cave. It's from eastern China. And this location is Sanbao Cave. Dongge Cave is from here. So these three caves is the most famous caves in China. All the published records mostly focus on the Holocene period. And we can see also some records that cover the last interglacial. Only 2 to 3 records covered like more than 3 glacial interglacial cycles. This map shows cave locations from different time periods. We still can see most records are from central China and southwest China. This for the last 2000 period. Another question should be noted is that when we use aragonite and calcite samples to make a composite record, we must do the delta weighting correction. These samples are from Shandong Cave from southeast China. In one single cave contains like primary aragonite and primary calcite, and also aragonite calcite samples. This calcite is secondary calcite. So we can see this is very typical needle-like crystal of aragonite, and this is column crystal of calcite. For the secondary calcite, we can see very clear in the calcium calcite crystal, the needle-like aragonite relics were still preserved inside. So this is a very clear sign to identify the secondary calcite. in experiment, data shows that this delta O18 equilibrium fluctuation between aragonite and calcite is about 0.6 to 0.8 per mil. And in Shandong cave, we just compare two samples during the overlap time period. You can see the delta O18 difference about 0.8 per mil for mean value. So that means like these values are consistent. For delta C13 difference between the primary aragonite and the primary calcite is about 1.3 per mil. So when we use both aragonite and calcite samples to make them composite record, we must do the correction for both the calcite, for both delta C13 and delta O18. Like this sample is from TBV cave, northeast Brazil. We can see very clear. It grows. This is aragonite and calcite, aragonite calcite, aragonite calcite. So when we use this oxygen isotope, we must first do the correction. We also find another interesting is for the secondary calcite is the delta C13 values between the primary aragonite and the secondary calcite are negligible. It's almost similar, no change. But for oxygen isotope, the values are changed to 0.6 to 0.8 per mil. So this is for secondary calcite. So when we use this primary calcite or secondary calcite, you should be careful. Okay, the second part about the interpretation was some delta O18 and also the debates, especially in the East Asian summer monsoon region. As we know, there are many influencing factors for oxygen isotope fractionation from precipitation to spectrum. Outside scale, just for precipitation delta O18, it can be controlled by the continental effect. It's like far from ocean, and the precipitation delta O18 is lower, and also the temperature effect. This is especially influenced by the high latitude, because in the monsoon region, the rainfall occurred in the summer monsoon season. So when it's like in the hot warm season, but for the high latitude, it's influenced by westerly. So the rainfall occurred during the cold season. So the temperature effect is very strong. Then is the rain-out effect. It means from the moist source region to the cave, totally rain out, like upstream rain out. Also like a local rainfall amount effect. This normally occurred for the convection rainfall, have the local rainfall amount effect. Normally occurred for one strong rainfall event, and also like circulation effect, moisture source region, the convection in the moisture source region, and also moisture source and moisture pathway. All these factors can influence the precipitation delta O18. For the epicast system or the inside the cave, so PCP will also influence the spectrum delta O18, and also strong evaporation and strong ventilation will result in kinetic fractionation. It will result in like increase in both delta C13 and delta O18. So when we got to sample, use it, when we want to use the oxygen isotope, we must first to do the test to test its like isotope equilibration or kinetic fractionation. Like Hendy promotes the Hendy test. It have two conditions. One is like in the same growth layer, the delta 18 values should be consistent. If kinetic fractionation happened, the delta 18 values on the edge should be higher than in the middle. Second is there is no significant correlation between delta 18 and delta C13. That's because when the kinetic fractionation occurred, and it will result in both increase in both delta C13 and delta 18, so it can lead to a positive correlation. Actually, most of the stalagmite grow very slow, so it's very hard to drill the samples in the same growth layer. So Daniel proposed another method to test called the replication test. It means use two stalagmite delta 18 records from the same cave or two nearby caves. If their records are replicated, then it means these specimens were formed under conditions close to isotope equilibrium, such as these two stalagmites record from Hulu Cave, MSD, the green curve, and MSILO, the red curve. We can see during the overlapping period, they are very consistent. So it means both stalagmite grows under the condition close to isotope equilibrium. Actually, when the calcite forms, the calcite water fractionation is controlled by the temperature. So we can, from the equation, we can see it's about inside the cave when the temperature increases 1 degree, the specimen delta 18 will decrease about 0.2 per mil. So for the Asian summer monsoon region, about the Holocene period, it's about like 2.5 to 3 per mil changes. So these changes need at least 10 degree temperature change. So it's impossible for 10 degree changes in the tropical region over the Holocene. So it means that the calcite delta 18 is dominantly related to the precipitation delta 18 and not the temperature. Okay, now we can, I think we can understand like stalagmite in the monsoon region is reflect the hydroclimate changes, especially like precipitation delta 18. So how does what factors influence the precipitation delta 18? In the last like 20 years, most specimen researchers in Asian monsoon region suggest specimen delta 18 can reflect Asian monsoon intensity associated with the summer-winter precipitation ratio, and proposed by Wang in 2001. Upstream total rainfall called the rain-out amount, proposed by Yuan in 2004, and also the spatial integrated monsoon rainfall between the tropical monsoon sources and the cave site, and all the summer monsoon rainfall in the cave region. Haiwei proposed this in 2016. But some studies suggest that specimen delta 18 in the East Asian summer monsoon region can't reflect the monsoon intensity. This suggests it reflects the circulation change variation. or the moisture source or moisture pathway changes. So this is how the debates come out. So what does the spectrum delta 18 in East Asian Sun monsoon region reflect? It reflects monsoon intensity or not? To resolve these debates, I think we need to first answer three questions. First is how to define the East Asian summer monsoon intensity. Currently, there are about 25 existing East Asian summer monsoon index. For example, the East-West thermal contrast, and also the North-South thermal contrast. Vorticity or Juno winds, and also southwesterly wind may rainfall amount. This is the 5 mean East Asian summer monsoon intensity index. Second is like how to treat different proxies from the different archives, like noise, paleosoil, marine and lake sediments. Third question is the interpretation of stalagmite delta 18 needs to be discussed on different time scales. So it means on different time scales, the significance of spectrum delta 18 should be different. Okay, following these three questions, I will introduce the variations of Asian summer monsoon recorded by spectrum delta 18 on different time scales. First is on orbital time scale and also the horizon. As we see, this Asian summer monsoon spectrum delta 18 records closely follow Northern Hemisphere summer installation with strong precession cycles, and the glacial terminations are separated by 4 to 5 precession cycles. But the seawater delta 18 record from East China Sea shows it was dominated by eccentricity 100,000 year cycle, and also obliquity cycles with almost no precession scale variation. It suggests that East Asian summer monsoon rainfall is more sensitive to greenhouse gas and high latitude ice sheet rather than direct installation forcing. Another seawater record from Andaman Sea also shows that the Asian summer monsoon rainfall peaked in the precession band about 9,000 years after the summer installation mechanism. In face with the records of South Asian summer monsoon winds in Arabian Sea, and also Eastern Indian Ocean, it's suggesting an influence of the South Hemisphere warming on Asian summer monsoon changes. These arguments were proposed by Stephen Clements and also his colleague. So this is called sea-land precession phase paradox. It's like for Asian summer monsoon record from Arabian Sea and other oceans surrounding the Asian continent shows a significant lag of about 9,000 years to Northern Hemisphere summer installation. But the spectrum records follow summer installation without a significant lag. We clearly check the model results. This is the Easy Earth model results. We can see this is P minimum minus P maximum means when the installation is high, the monsoon is strong. We can see northern China and the Indian continent really have more rainfall. It's wet, but South China and the East China Sea, South China Sea, and also the Bilbao Andaman Sea is dry. So it should have like 9,000 years lag between land and ocean. For precision Delta 18 results, model results also show a similar, like this seawater and urban sea and Bay of Bengal is different from the precision Delta 18 inland. Another model results from CESM, it shows a similar results. You can see when the also the P minimum minus the P maximum means the summer installation is strong, it's high, the monsoon is strong. You can see northern China and Indian continent have more rainfall, but the ocean is dry. So from this view, we can understand like this: the ocean rainfall should have like 9,000 years lag to summer installation, but the land rainfall is closely follow installation. So this 9,000 years lag is not contradictory. It's just like it's consistent with the installation and the monsoon change. For the Holocene period, here shows all the Holocene records from Eastern China. All the records reflect the strongest Eastern Asian summer monsoon occurred in the early Holocene. But the lowest sequence indicates the Asian summer monsoon strength from 5,000 years ago, and some lake sediments show mid-Holocene optimum. This is different from Splasium .2D records, with the strongest Asian summer monsoon occurred in the early Holocene. So we collect all the Splasium records and reconstruct rainfall records from Eastern China. From north to south, we divided to 6 zones. We put all these records in these 6 zones. We can see for Delta 14 records from north to south is almost similar, but the southeast China, the Splasium records are different. Other regions are similar, but for rainfall, we can see for North China is the Holocene optimum occurred in the early Holocene, but for South China is in late Holocene. It's like a dipole, just like Professor Cruz introduced in the morning for South American monsoon region is similar. This color curves is we use all these Splasium values in these 6 zones. We calculate the mean value, and the black curves are the data extract from the CAA and 5 simulation results. We can see they really have a good. They are similar. They have a coherent variation. And the right side is the reconstruct rainfall proxy. The color curves from also is the reconstruct records, and the black curves are the data extracted from the annual rainfall, we can see they are also consistent. So these two profiles shows that the specimen Delta 18 show a large scale consistent variation, but the rainfall are really different for different locations. The rainfall are different. From this view, we also use Cosmos isotope modeling results. It shows that for Delta 18 values, the large scale when the installation is strong, it means monsoon is strong. The large scale precision Delta 18 is lower, but for rainfall proxy. But for rainfall, North China is wet, South China is dry. So it's different from precision Delta 18. The left is annual results. This is for the summer season results. For oxygen isotope, it's similar to annual value. But for the summer monsoon rainfall, we still can see some difference. Like in the early horizon, in South China, the annual rainfall is less, but for summer rainfall, it's still high, it's still wet. So it can also explain some difference from the different proxy from different archives, because different proxies they have the seasonality bias, like sediments. Pollen from lake sediments, it can influence by evaporation and also its annual rainfall or summer rainfall. But for specimen Delta 18, it's mainly influenced by the annual rainfall. Recently, our group have another work by Tian. This paper was just online yesterday. And he do the multi-proxy from Queen Cave. This is a famous specimen published by Dominic Fleetman in 2003. This is his oxygen isotope record. And in our group, Tian analyzed other proxies, like this is the fluid inclusion and Delta O17, C13, urea ratio, and also trace element. All other proxies show that for early horizon, it's dry. So the oxygen isotope shows that early horizon monsoon is strong. So monsoon is strong, but the local precision is less. So this is also like Clement's argument. It's contradictory, but I think after from the model from the large scale, we can understand that it's not contradictory. It's because this easy Earth modeling results. We can see this is 8,000 years minus pi. The result, it means like when the installation is high, the monsoon is strong. We can see for Queen Cave, there are more moisture from African monsoon region. So it's a remote distance. So the remote moisture from African region result local precision Delta 18 lower, but the local rainfall is not high, it's less. But the Delta 18 values is really negative. So from this view, we can see for early horizon, maybe the North Africa summer monsoon have a large contribution to this location. So from this view, we can see the Queen Cave is also mostly reflect the large-scale circulation changes. Yeah. So we can see it also reflects the Indian monsoon intensity, but this intensity not in the rainfall amount. Yeah, this intensity means overall monsoon intensity. It includes like the convection from the moist source region and the total rainfall from the moisture source to the cave location. Yes. A short summary for this orbital time scale. First is the Splashdown Delta 18 in East Asian Sun monsoon is largely controlled by the large-scale circulation and also the shift of monsoon rainfall belt. Different from the spatial temporal pattern of horizon rainfall. A coherent orbital scale splashdown variability across the most Asian monsoon region is it can reflect the overall monsoon intensity, which is forced by the North Hemisphere summer insolation. And the overall monsoon intensity is not equivalent to monsoon rainfall amount, but it is a manifestation of the large-scale atmospheric circulation. And divergent phase relationship with North Hemisphere summer insolation between Splashdown Delta 18 and other pockets are consistent rather than contradictory to the North Hemisphere summer insolation forcing. And the Splashdown Delta 18 and the rainfall records reflect two different aspects of the monsoon dynamics. Like Splashdown Delta 18 mostly reflect the large-scale circulation, but rainfall records is only reflect local hydrology. So these results may largely help to reconcile the divergent view of horizon Asian monsoon variability. Here are the reference we published in last few years. Okay, second part is about the millennial time scale. For millennial time scale, we can see the abrupt climate events inferred from Splashdown records that show a clear antiphase correlation between Asian summer monsoon and South America summer monsoon region during the last glacial period. It means like both abrupt change on millennial scale is triggered by AMOC. This is another work we use very precise chronology from Cycle Cave Spain and also Shandong Cave from southeastern China to reconstruct the timing and structure of younger dries. For Cycle Cave, this Splashdown Delta 18 is dominantly influenced by temperature, so it can compare with the ice core, Greenland ice core Delta 18 directly, because both of them are influenced by temperature. We can see this gray curve correlated very well with the N-grape Delta 18 records. And Greenland N-grape Delta 18 records at this period is age average is about 100 years, but Cycle Cave average is about 30 years. So it means the N-grape chronology at this younger dry period is no problem, but we can decrease the age average from 100 to 30. And for Shandong Cave from southeast China, this is aragonite, have really high uranium concentration, so the dating error is very small, only about 15 years. So this 15 years error can compare with N-grape directly, because we already use the spin Splashdown decrease the N-grape there are 2 records from 100 years era to 30. So then we can compare them. We can see the East Asian summer monsoon closely follows the Greenland temperature change. Yeah, because this area is 30 years, this area is 15 years. The occur, see the start and the end of East Asian summer monsoon during this younger dry event closely follow the unraped records. For other records from Asia and also westerly range, we can see the start and the ending time also almost similar, but the responding time during the Asia and the westerly region is longer than the unraped. We also compare this north and south bipolar ice core record. You can see when the North Greenland cool down during the at the beginning of young dries. After about 200 years, Antarctic start warming. So this is bipolar seesaw. We can see very clearly from this close comparison. Another work from northeast Brazil, TBVK. This sample grow in young dry period. The lower part is calcite and the top is regnite. First, we can, as we know, calcite grow in a wet condition, but regnite grow in a drier condition. So the young dries first we can divide wet to dry. So this is oxygen records. You can see the first part of young dries is wet, second part is dry. And also for the first part, it can show drying trend from the beginning of young dries to the middle young dries. So we also compare other records during young dries period in the Atlantic section. We can see from south to north, it's globally northward migration of the ITCZ is preceding the polarward shift of the westerly and also the polar front in northern high latitudes within the young dry period. Yeah, unraped warming is at the end, at the last. So we also compared the temperature record from Antarctic and also this is the AMOC record. You can see at the start of young dries, AMOC start to resumption, and also reorganization of the atmosphere in Atlantic. Another work during the Heinrich II event, the first author Xi Yu Dong, he's sitting there. If you have more questions, you can ask him directly. And this record show from India. This record, from India, Cherrapunji. We can see its structure during Heinrich II have a very good relation with the curriculum record from Hungary, from Hungary and also other ice core record. Yeah, because when the H2 event occurred and the North Hemisphere is cooling and westerly move southward, So the summer monsoon decreased. The westerly can transfer dust from the Sahara Desert globally in 2 weeks. So the monsoon intensity can correlate very well with the curriculum concentration records without the lead or lag time. So this is why we can correlate with the Delta 18 to the curriculum record directly. So it means that if we correlate this structure closely, should move the Greenland ice core to old direction about 320 years, and Antarctic record should move 400 years. So it means our spectrum record chronology can really correct the ice core chronology. We also find another interesting is from the this record from northeast Brazil during the Haiwei event. It's ending earlier than the northern high latitude. So it means a more active role of the low latitude hydrogen dynamics underlying the millennial events than previous thought. It's because the weekend South American monsoon will result in a small Amazon plume in this region, and the long-term drying trend in the South American domain will result in higher sea surface salinity. It will finally increase the AMOC. So it finally will contribute the AMOC strengthening. Then it will lead the recover the end of the Haiwei 2 event. This is our lab recent work because we just use the precise urim-thorium dating and also the layer counting, conformal layer counting. We can build a very precise chronology. In the middle, the black arrow bar is our spectrum chronology errors, and the red dashed line is the ice core chronology error. We can see the error is reduced an order of magnitude. So use the spectrum chronology can really make like a benchmark for the paleoclimate study. So I just give a short summary. It's not a conclusion. It's about precise chronology of spectrum record. It will be very used as a benchmark for climate study. And this precisely dated high-resolution spectrum Delta 18 record could provide a lead-lag phase between the high and the low latitudes. It's very useful to understand the timing and the structure and also dynamics of this abrupt climate event. For the centennial time scale, the Wanxiang Cave record, it shows Chinese culture, the Chinese dynamics evaluation are influenced by the Asian summer monsoon. It was forced by the solar variability on centennial time scale, and also on centennial time scale, the spectrum Delta 18 can reflect dry and wet, not like the orbital and millennial time scale. On orbital and millennial time scale, it normally reflects the monsoon intensity or to see the circulation. It can't directly reflect the rainfall amount, but on centennial time scale, it's quite close to the local hydrology. Here I show another work. We use the spectrum records from Southeast China to discuss the climate change with the cultural evolution. And in Southeast China, this location have a very famous culture called the Liangzhu culture. It's about 5,000 years ago, and at 4.3 thousand years ago, it suddenly collapsed. This culture is really highly developed. It have a very large water management system with high and low dams, and also the city walls with very high level jade article industry, and also famous famous rice. At that time, people start to plant rice. So it's 5,000 years ago. But suddenly, at 4.3 thousand years ago, this culture collapsed. Why it collapsed? Have many hypotheses about wars and extreme cooling, and also the sea level rise and flood. But still in debates, most archaeologists support the flood hypothesis. It's because there is a silt layer covers the Liangzhu culture layer, but still have no high resolution paleoclimate records. And also, like this period is very close to 4.2 event. As we know, 4.2 event in Central Asia is a dry event, but why in Southeast China, many evidence show a wet climate. We use stalagmite from Shenlong Cave and Jiulong Cave. These two caves is about 300 kilometers from the Liangzhu culture. And this is the two cave oxygen isotope. Yeah, they satisfy the replication test. And we also calculate the correlation between oxygen and carbon isotope. They are positive correlated at a centennial scale. It means like both the carbon and oxygen isotope was influenced by covariation of hydrological hydroclimate change. Okay, this is oxygen record, and this is a carbon isotope record. This is from Jiulong Cave, and these two records is oxygen and carbon record from Jiulong Cave. These two are from Shenlong Cave. So we also calculate the spatial correlation between summer rainfall in the study area and the regional rainfall. We can see for the study area is positive correlated to the larger area in Southeast China. That means these two cave oxygen record can reflect the large-scale precipitation change. And also we calculate the delta 18 correlation with the precipitation. It shows a negative correlation. It means when the specimen delta 18 value is lower, there are more rainfall in this region. So we can see a really negative spike occurred at 4.3. Yeah, this is almost the most negative value during the whole Holocene from the oxygen isotope. It means it's a really wet condition. We closely see this period. We can see this here we use carbon isotopes because carbon isotope are oxygen and oxygen isotope are positive correlated during this period, and to avoid other effectors on oxygen isotope, we use carbon isotope here. And this orange column is the dam reconstruction by the Liangzhu people. This uses the carbon-14 dating. It shows this dam was built start 5.3 years ago, 1,000 years ago, and stopped at 4.4 thousand years ago. Because this period is an extreme dry period. And after that, at 4.3 thousand years ago, from extreme dry changed to extreme wet. So for this region, like this is floods in 1998. This is largest flood in the last 50 years. So during 4.3 thousand years ago, it may occur a similar situation. And after this Liangzhu culture ended, collapsed at 4.3. After that, it's 300 years wet period. During this wet period is another culture called the Guangfulin culture. This culture is poorly developed than Liangzhu culture. And also the culture, there's a cultural museum in Shanghai. And this old building is built underground water. It's just like the condition at that time. And after that, after this 300 wet period is extreme dry period. At this period, it's 4,000 years ago. It's the Chinese first dynamic was built by Great Yu. Yeah, there's a legend. It's about Great Yu successful managed the river flooding about 4,000 years ago. Then he built the first the first kingdom of China. But it's impossible for people to control water at that time. So we think this is because maybe ascribed to climate change from dry to wet. For this possible climate dynamics is because when the monsoon decrease, North China is dry and South China is wet. And during the El Nino years, we can see North China is dry and South China is wet. So from the horizon, we can see around 4.2 thousand years ago, the monsoon intensity decreased. So South China is dry, it's wet. And also this time the SST from Western Pacific shows large variability. It means this time also El Nino activity frequency is very high. So like both weakened monsoon and increased El Nino both result this extreme flood during this period. And also from the whole horizon, we can see also frequency increase a lot at the late horizon. For the last 100 years, it also shows this when the monsoon decrease, it shows southern wet and northern dry pattern. So for the future, maybe IPCC predict in the next 100 years, monsoon will still East Asian monsoon will still decrease because the AMOC is decreased. So it means like North China will be persistent dry and South China wet. Here is another sample from Southeast China. It can show very clear bonds, growth bonding. We use micromeal. We can got really high resolution from a signal to monthly resolution of both oxygen and carbon isotope. It shows a very good correlation with the ENSO and the PDO, the Pacific dictatorial oscillation. So we can also find divergence occurred since 2005 under the global warming. So a short summary is like precise and high resolution spectrum Delta 18 records is very crucial to understand the relationship between culture and climate change. And also Delta 18 records have the potential to evaluate or to predict the future climate change. Okay, thank you very much for your attention.
Thank you very much for the great presentation. We have time for one quick question. Yep.
Hi. In the Holson records you were discussing, could you see signatures of westerlies? And how far eastwards were those signatures from?
Westerly, you mean westerly?
Respiration. I mean, 18O water isotope signature of westerly's respiration.
Westerly? Sorry?
In the spectrum records from the eastern China that you showed, could you identify using 18O values of the oxygen, the influence of westerlies every time there was an intensification or anything like that?
Oh, sorry, I didn't understand your question.
I guess is it that the westerlies are influencing Delta 18 at your site, and are you certain about that?
Okay. I think it's mostly influenced by the summer monsoon precision Delta 18. Westerly, it can influence, but it's very few influence.
Yes, so that's why I was asking, how, for example, if you look at the ITCZ's position now, the extent in which the westerlies come southwards, that has migrated over time, right? So in the records, when we move from, say, the western records to the eastern records in China, how far east can we see that influence?
Actually, southwest China is different from east China. It's because the first is the rainfall belt change. Second is the for southeast China is influenced by the annual rainfall, but for western China and southwestern China is only influenced by the summer monsoon season. Yes.
Discuss this with you.
Okay. Great. Well, we don't have any more time for questions, but feel free to ask more questions at the coffee break, which is happening now. And then I think at 1:15, posters will start being a thing. So. Great. Yeah. We'll see you there.